Hey, everyone.
Hi, Joe.
Hi, Joe. How are you?
Doing okay. So here's our agenda for today. And we just have to wait for enough people to show up, even though we're not voting on stuff. We should really have quorum. And I guess we have we should also be reviewing the security OPI security policy pull request. So if you haven't looked at that yet, you should go look at it. Yes. So, Oren, you're standing in for Tahi?
Yes.
Who's iPhone 234 out of curiosity?
It's Laura Hendrickson. Sorry, I
Oh, no worries.
set that up before. I have to putter around my house for a few minutes while you guys chat.
Yeah, no worries. Yeah, welcome. It's
Thank you.
just
Yeah, it's nice to know who's on the call, right?
well, yeah. I just recognized everyone, you know, all
Except for iPhone 234, which is not a particularly humanizing name.
yeah, I mean, I kind of like it, but you know.
You can call me that for the foreseeable future. You can say, "Hey, iPhone 234, how was your weekend?"
Exactly. All right. So we have so all right, we have quorum. All right, any additional agenda items or announcements that anyone wants to make, or any topic that we ought to be considering, because I can record that for future agendas, or we can take notes on it.
Just an announcement. Satananda will be replacing Prasoon for good. So Prasoon has moved to as a board representative, and Satananda will be the TSC representative going ahead.
All right. So there's no more Santana for Prasoon, no problem. Okay, but I don't see him. All right. Anything else?
Real quick, a lab announcement. Everything was signed, and I think we're just waiting on one piece of information, unless Sridhar got it yesterday, but
yeah. So all the signatures are finally done. I'm just waiting for the account number. They will send the fed the details to the system itself. The system has to generate. So maybe today we should get an account number, and I will share it. Once we have the account number, the complete address is ready, then we can start shipping.
Okay. I guess the last thing is the SDC agenda is firming up, and depending on how you count, we have 3 or 4 or 5 OPI related talks.
oh, good.
Pretty much all of the
I was only
talk.
on 3.
Yeah, pretty much all the talks that are in the DPU track have something to do with, I believe, mention OPI. I'll double check. I'll double check here. But it was very good. I mean, the agenda committee, you know, was happy for this. We have a nice DPU track. So it should be an interesting event.
So one of the talks, the demo POC and lab talk that we have.
Yep.
I'm the one who submitted it. I'm not certain I'm the one that should be presenting it. I'm on the schedule as the one presenting it.
That's right.
Is there someone else?
Because you submitted it.
What's that?
Because you submitted it. That's how
Right.
SVP works.
Right. Because I submitted it. I'm just wondering if there's someone else that ought to replace me for that is actually in San Jose. For me, I'm not certain I'm going to get budget to travel. Is my
Okay.
issue.
So that is a good question, actually. And so maybe interesting. Maybe Venkat ought to do it.
Yeah, I was hoping he'd be on and I'd be able to ask him today, but
All right. Yeah, let's see if that can happen. Because I think he would be the better choice.
yeah. Is Murcha in San Jose?
You know, I don't know.
No, Calabasas.
Calabasas, okay.
Okay. So, you know, that's not too bad a travel if you could get, you know, travel.
Right. Yeah, it's our fiscal year starts October 1. And we haven't been handed our travel budget buckets yet. So I'll work with Venkat and see what he has to say. Anyone else in the Bay Area that wouldn't have to travel that's interested? Anyone on this call? Okay.
I'll be there. This is Dan.
Okay. Would you be willing to be a backup for that demos, POC, and lab discussion?
Yeah, I can be a backup.
Okay, thank you.
All right. So we'll get one of those worked out. All right. So let's start normal agenda. So Dan, go ahead and share. And let's walk through IPDK. And what I really like to do is, so what are our opportunities to add more to OPI? You know, basically put general stuff into the OPI repositories and make them part of OPI off of what you're doing in IPDK, right? So the more common we can make elements, the better off we are, I believe. And I think you agree with that. So as we go through, let's talk about opportunities for additional things. Like the storage API was a great success. You know, everyone was happy at the end. Let's look for more opportunities that are similar. All right, take it away.
Yeah, absolutely. So we just did the 2307 release. The release notes are online. Let me go through each one. Actually, let me talk about the one that was not released in 2307, which was the IPsec recipe. So you know, IPsec is a really good example of our approach in IPDK, is that what we are doing is we're building some middleware to take an existing application that people are already using. In the case of IPsec, it's Strong Swan. We take Strong Swan and we work underneath the implementation of Strong Swan to integrate it into our a set of our devices. In the case of Strong Swan, we have integrated that to just one device, which is the Intel IPU E2100. That's the Mount Evans device. And so the user that protobuf in OPI for OPI security. So the user either uses the kernel interface of Strong Swan, or they use the OPI security interface. They program the tunnels that they want, and then those tunnels get replicated into the IPU. And that is the same sort of design pattern that we have in all the other recipes, is that we want to integrate existing APIs, existing applications, and existing usage models into the IPU, so that your applications go faster, are better, more secure, without having to adopt a unique new interface just for IPU, or just for a switch. Instead, you're going to be using the same applications that you have before. So that's really similar to what we did in the virtual networking recipe. So in networking, if you can see this, we have something called the P4 control plane. And so what the P4 control plane does is that it is integrating the Linux data plane into a couple different implementations. We have our DPDK data plane, which is entirely bringing up your system. It's also our data plane for our FPGA IPU. ES2K is the Mount Evans IPU, and this control plane also runs on Tofino. And what the P4 control plane is doing is it's doing all the work to integrate the Linux functions like Linux Bridge, VXLAN, routing, to get the data plane underneath FRR. All of the functions that you would sort of be familiar with if you were networking on a Linux host or on Sonic in a switch, and put that into one of these three data planes. And in the case of Linux networking, we are converting all of this functionality from netlink sockets into SI, and we're converting everything into SI to make it easier for us to integrate Sonic into this stack, right? And have Sonic be a sort of a switchable operating system option in the future. So we also have integration for OVS. So we used to call this solution P4 OVS. So in here, there's inside the environment. OVS integration allows you to, you're running the I guess the kernel version of OVS. So setting up bridges, creating tunnels, all these types of things. The change that we've made is that instead of using OpenFlow inside of OVS, we've enabled the use of P4. So the P4 allows you to encode a lot more information about your application in terms of the type of table that you have, the type of transformation on the packet that you're going to do. And that makes it a lot easier to get that into hardware. And so that's the main difference between using sort of regular OVS versus the P4 control plane. So the most common example in OVS is when you go and OVS will do virtual layer 2 domains. It'll when you have a bridge, so you have to you see a packet on a tunnel and you want to MAC learn that MAC on that tunnel. Inside this sort of modified version of OVS, you'll push a P4 runtime message over the P4 runtime to add that MAC address into the pipeline, and that's it's sort of a toggle inside of OVS just between OpenFlow and P4. Like, oh, I'm in P4 mode, so I'm going to send that MAC learning message over P4 instead of OpenFlow. So that's how we integrate OVS into the system. So there's details here, and inside the user guide, we're building out a set of examples on how all of this is run. So we'll start to have examples on sort of using OVS in some common use cases, just using the Linux kernel. So no OVS, but just running with the Linux kernel, and also integrating with OVN. All of these functions. And the nice thing is that, our goal is that the user doesn't ever have to touch P4 or sort of mess with it. It becomes an expert mode. 90% of the functionality that we're enabling here is all part of the Linux kernel, part of OVS. And is utilized by OVN. And what we've done is we've just replaced the OpenFlow with P4 just to make it more programmable, more expandable. You have your custom tunnel, you have your custom ACL, you can use P4 for that. That's a good example of how we also integrated the same philosophy as networking and IPsec, where the user uses the same CNI and builds their cluster in exactly the same way that they are doing it today. But underneath the CNI, we have offloaded a select number of networking functions. The endpoint discovery, load balancing, obviously the forwarding, and all of the routing. So all of the NAT functions to interconnect all the pods. All of that is done in the IPU or switch. And so that's giving us a humongous improvement in performance and latency. And so actually, let me go to the release notes here. Without having to change the CNI interface to the user, if they're using eBPF, they can continue to do so. If they're using any of the advanced features, the CNI that we are testing with today is Calico. It's a very popular solution for Kubernetes. So the end user's experience doesn't change, and also the administrator's experience doesn't change. It makes it easier to manage and go and debug, look at stats. That all of that is very common between the offloaded version and the unmatched to also implement this for OpenShift and for Cilium. That's sort of the next steps in implementing the Kubernetes recipe. And once again, we used P4 to do all of the sort of dynamic load balancing and get all of the ACLs into the pipeline. But the end user just uses Kubernetes, so they don't care about P4 or how we ended up integrating it with the rest of the applications. But they sort of benefit from being able to, for us to be able to meld a custom pipeline for this CNI. And it's possible that different CNIs will have different pipelines. Certainly OpenShift, which is based on OBS, will have a different pipeline and different P4 program. And so that is where we have sort of added flexibility. Something like an OpenFlow just doesn't lend itself to that kind of customization. So here in the release notes, we get into more detail as to what we did in this 6-month span. We'll have another release in January next year. So for storage, we made a lot of progress and also switched the storage recipe to OPI repos. And this is absolutely a future recipe that would be developed for IPDK. The storage also switched from the SPDK SMA API to the OPI APIs that were defined in the work group, and also the language changed. It also changed to Go. We added new features for QoS. So we have device level rate limiters for NVMe, and we have we enabled quick assist type style storage encryption decryption. So we can do data at rest encryption if there is a accelerator on the compute platform. We can leverage that to encrypt the data as it goes in and out of the system. Now, our storage recipe for IPU DPU is entirely on the initiator side. On the target side, it's still, you can use an IPU DPU there as well, but it's not really offloaded. It's just being used as a target. So all the work that we've been doing in this area is on the initiator side. Sorry, I'm going really fast because it's in a random order, but that's storage. Networking here. Is that we have been refactoring things. Is that we have been simpler to upstream these changes back to OBS. So that was a big part of the refactor. And at the bottom of networking, we have something called TDI, which is the table-driven interface. This is our generic interface that allows us to integrate to all the different devices. So in this case, DPDK are 2 IPUs and our Tofino switch all can speak TDI, and so they can each have their own different flavor of P4 where needed to be able to integrate with the recipe. And in the API, whenever we get together to talk about APIs, this is an area that we really want to bring to OPI, is this layer to be able to support different devices and different targets. This is also the same layer that we've been using to convert from Sonic and Dash into a common layer, sort of underneath the syncd process. And this all came from the work that we did on our barefoot switches, Tofino switches. So we think this is a really interesting use that non-Intel devices could use TDI too. This is either there are implementations on non-P4 devices out there today. So this is something we definitely want to discuss and offer to OPI when we do have that API discussion. TDI is also related to something called P4TC. It's P4TC is the same structure as TDI, but in the kernel, while TDI is a C++ user space interface. So the same kind of concept where it's a data-driven interface meant to be friendly to integrating with programmable devices. They're of the same design, driven by some of the same folks. Let's see, big limitations list. Kubernetes talks about here the functionality that we're supporting in the release notes. Something that all of the recipes do is they use TLS by default to connect all of the RPCs together. So inside the recipes, encrypted and is encrypted by default, so that it's more secure. Also inside the Kubernetes recipe, we have a feature of Mount Evans, which we utilize, which is part of scalable SIIV, which are dynamic subfunctions. So these subfunctions don't require an SRIOV VF, so you can scale them much higher. And that is a key requirement for Kubernetes network offload, is to be able to offload the forwarding between pods, is that you need to give each pod its own interface so that it can still run its Cilium or whatever on top of that interface, but then to route in between them or route and NAT them out of the system, they need to have their own interface. These dynamic subfunctions scale much higher, quicker, and easier than SRIOV. So that's why we use it in the recipe. And in our different talks that we've given on this one, we've talked about the importance of these unique interfaces for each of the different pods. So there's storage, and then to reach back in the 2301 recipe is where we last released IPsec. The IPsec has a P4 program that you can look at. And with our P4 and OpenConfig is out on the website. So I would call it a design preview. And our goal is for 2401 for this to be a full-fledged recipe, just like the others. We do use OpenConfig in both IPsec and the networking recipe. And in 2401, we hope to make it more of a first-class citizen. OpenConfig today in the networking recipe, don't know if we talk about it in the release notes or not, but we're using OpenConfig for ports. So configuring the port speed, quadfurcation of a port, QoS, these types of things. We're using OpenConfig, and that OpenConfig can be used on a switch, on an IPU, on a DPDK pipeline. We're trying to get that commonality, which we didn't have, even though all these things supported OpenConfig. They had slightly different models for things that should be the same. So we are pushing to have a common OpenConfig interface for things that are commonly done in that way. And so you have certain overlaps, like it'll be likely that you could create a lag a couple different ways. You could create a lag over OpenConfig, you can create a lag using the Linux kernel, create a lag over P4, and that's okay. So it's good that you can have different interfaces for what ends up being the same function over TDI. Goal here is to create a switch around, the goal on the website in the open source that is bridging a set of infrastructure applications to a set of devices. And in order for that device to fit into underneath that middleware, the key is that it is able to support the set of functional interfaces over TDI to program those functions. So not every device has to support every function. Our Tofino doesn't support IPsec, but it can still be used and integrated for the functions that it does support. Okay, that's all I had.
All right, questions? All right, so let's summarize just in one sentence each the spots where you think there's code to be contributed back to OPI. Basically, what should be moved from IPDK given this release to OPI?
Yeah, I think that we could evaluate entire recipes to move over to OPI. The non if we were to move the networking recipe over to OPI, we're enabling OVS, OVN, Linux, and SCI integration. We're adding that to OPI, and folks who want to leverage that as a target would need to support the TDI interface at the bottom, and users would be able to then use all those functions on the top side. The Kubernetes is really similar, is that we would offer this to OPI, and that would enable Calico integration to OPI. IPsec is potentially the next, probably the easiest one to switch over first, in that it is already supporting an OPI interface at the top, and at the bottom it's P4 runtime and OpenConfig. So that one might be the next one to try to convert, because it's so simple in its implementation, easier to adopt than some of these other ones. And then we do have other recipes around Dash, and that we're hoping to add in a future release, and that's something that we could consider when we bring into the community, is to bring it in directly into OPI, as opposed to bringing it first into IPDK to get right before it goes into OPI.
Right. Okay. Would you mind making a list of those, and either do a pull request, or you can just edit and add them to the notes today? Just
with all
what you said.
And yeah, with all the.
Yeah.
Oh, sorry. Go ahead.
Yeah, I was gonna say, just make a list of them, and you can either add it to the notes for the TSC call, or send it to me and I'll add it to the notes.
Okay.
And that way we can talk about it in this call and evaluate more which ones we ought to agree to.
Okay.
All right, Alad, you had your hand up.
Yeah. Hey guys, I think that this was discussed before, and to be honest, I don't see a lot of new stuff here other than the fact that now it's released. If there's an extra layer that is in there, it's not a great fit for anybody who's not using P4. Meaning, if you want to use P4, great, but this is for me not a good fit for OPI. Meaning, the extra layer of translations that there is inherent in the solution is not a good fit for anybody who's not using P4 or even specifically this implementation. Therefore, again, it's very specific and not an exact fit for OPI in my mind.
Yeah. So
Go ahead,
Dave. We realize there's other implementations of things like OBS, out there that don't use P4. So I think that for something like an OVS, which has different, it has a couple already existing hardware offload interfaces. I think that when it comes to OPI, the very first step would be to the things that OVS does, and the things that the Linux kernel does, and the things that get converted over SCI. Like, I would start from the top down. So we don't have to go in and I have no intention of saying OPI should enforce that everyone uses the P4 runtime interface at the bottom of everything. So no intention of doing that at all. I think that this should be considered as an implementation of a set of common control planes inside this marketplace, and not we're not assuming that anyone's going to enforce that you have to use P4 runtime. So that's not what is what's being proposed. Yeah, we wouldn't do that to you.
I understand that, Dan, but we need to pick a direction. And again, we had this discussion before. If we want to have various vendors bring their implementation of how to handle various workloads, like StrongSwan, for example, and say, here are a few ways to do this. That's great. I mean, it's a very nice gesture, but it still means that different vendors doing it different ways. The whole idea for OPI for me is to have one way of doing it that fits a standard. And my take on this is, that we need to have those northbound APIs that fit everybody. And then under the hood, people can translate it any way they want. So whether it's CNI or any other type of class of APIs, that's fine. But we need to define those northbound APIs, and under the hood, whether it's P4 or OVS or something else. Again, if it's Kubernetes, then it's Kubernetes. Everybody does what they want, but as long as we agree on how to connect to it, that would be beneficial in my mind.
And I think that's just an example of, okay. Yeah, I think that these are just examples of, instead of, adding our own, N+1 API, these are examples of taking existing applications that have their own APIs so that the user doesn't have to change their interface. So I think it's just that's a different top side approach to what you just said. So I think that is more of what we should be talking about in the TSC is, instead of, creating a new API for Kubernetes, maybe we should be thinking about how do we make it so that people's existing APIs in Kubernetes are preserved.
Any other comments? All right, so we'll need to, so Dan, if you could, a pull request would be ideal, but again, any form of just writing down what the contributions ought to be, what you believe they ought to be, so that we can get everyone's comment on them. It ought to be a pull request, but we'll take any form. And again, just it can be fairly short. It can't be a three-word bullet, but needs a little more than that to describe it. And then we can decide on what should be brought into OPI.
Yeah, could we do it this way? So, I mean, today I just wanted the agenda was just sort of like, let's talk about IPDK. Could we make it a separate agenda item to say,
Exactly.
okay, that would be better than just trying to slide it into the notes. Then I could just
No, what I was thinking is if you write it down, then we'll have something we can go through item by item and discuss them. And then if we have a pull request, we can provide written comments. And then we'll have a TSC agenda call to go through and decide what should and shouldn't, and if something needs to alter form, or if this is, and so on.
Okay.
So we ought to do it as a medium formality process. So write down the proposal, which is just what you said, right? Just write down the proposal. Then we'll have the discussion like we just had with Alad, and then we'll vote on, basically vote on each item, sub item, and say, what definitely has to go in, what should be reworked and go in, and agree to that. And that'll require actually discussing some of the details of how it's done. And that I agree. We need like a pull. We basically need a pull request to discuss it. Again, it doesn't have to be a novel, but
yeah. So I'll focus on the pull request, and then we can.
Then I'll schedule. As soon as you do the pull request, I'll schedule it on the agenda, because I think it's very useful and necessary for, again, we want OPI and IPDK to be as close as is reasonable, and all those good statements we've made in the past. All right, any other comments? All right, thanks, Dan. That was great. So I'll look for that pull request, and again, reach out to me directly if you just want to discuss anything. Okay, Tim, you're up.
Okay, thanks, Joe. So as much as I enjoy having the floor, I'm actually going to pass it over to Paul, who's actually got the material.
Fair enough.
And you seeing my entire desktop or just the share? Looks like the entire desktop. It's paused, resume.
Keep saying double click to enter full screen mode. Oh, there it flashed for a sec.
Working on it. Seeing it now?
Yep, there it is.
Okay, perfect. So you may remember we presented this back in, I believe it was March, maybe even early April, to discuss a proposal that F5 was bringing forward to make Nginx open source, an application that ran on the DPU, the first workload, a workload that ran on the DPU in the compute complex that's on those DPUs. It was to provide a traffic pod, a application or workload pod, and a target pod. So providing those three things as a way to create a hardware acceptance test, an acceptance test that actually uses the hardware that we could submit back to OPI as part of the test suite. We are, like many companies these days, we ran into a couple of resourcing hiccups. We had difficulties sourcing DPUs. We sourced them, we unsourced them. We finally, in the last couple of weeks, we've received both Marvell and NVIDIA DPUs. So we have those in our lab, and we're bringing those up, and we're provisioning them right now. We have another. We at one point lost the engineer that was working on this. We have another that is now focused on this and working at it day by day. Where we're at right now is that we've got the network set up. We've got DPUs installed in servers, and we're working on just validating that we can get the Nginx proxy running on a DPU. We've got a few minor things that we're working on with the DPUs themselves, the out-of-box experience, ordering the right cables to connect things, ordering the right NVMe drives that are needed, figuring out how to get all of those things connected. There's not an easy path to do this. I think everybody recognizes that, and that's why we're doing OPI. So we're in the process of getting the base level, nothing with OPI, working, just so we can validate that we've got network set up correctly and that we've got the host set up correctly and the DPUs provisioned in the proper way. As we move on, we're going to finally get to a place where this is what we're hoping to deliver, is an Nginx proxy pod running on a Kubernetes distribution. At this point, we're using a Red Hat SNO, single node OpenShift, on the DPU to be the container orchestration layer that the Nginx proxy pod sits on. We, F5, would like to get to a point for our own work where we can cluster that with other Nginx proxies out there. And we'll just happen to use an Nginx web server as because it's open source, we know how to do that. And we'll use that as the target server that the Nginx proxy is proxying traffic to. And really the traffic generation, we're not certain what we're going to be doing with how to do the performance testing of this to see what the possible throughputs are. For OPI, what we're looking to do is just how do we use the OPI APIs to provision this stuff, and can we and is it possible, is there a gap in provisioning workloads on a DPU, and then start the discussion on how do we close that gap on provisioning workloads on a DPU. Any questions there?
No, pretty clear.
Okay, just to let you know, yeah, we ran into some resourcing challenges. That's why we did not get it done for the SmartNIC Summit. We were hoping to have it done then, and but we are working on this project, and that's the status of where we're at now.
And one of the readouts from this will be, hey, OPI ought to add XYZ in addition because we needed that.
Yes.
Okay.
Yes, and one of the readouts that we're also doing for each of the vendors is your out-of-box experience needs some work. And by out-of-box, we mean you open the box, you take whatever documentation you have, and how easy or difficult is it, what road blocks that we run into to get these cards provisioned in a simple manner. And then we'll do the same with, okay, now what's the out-of-box experience using the OPI APIs to provision these devices as well. We'll provide that feedback.
Great. Any questions? A lot.
I'm sorry if I missed it, but Paul, what are the performance matrices that you're using for this?
The performance. What are the metrics that?
Yeah, what kind of performance are you aiming for? And hopefully, what kind of table do we get at the end? Because I think that what the deployment partners want to see is before and after, right? They want to see before we were putting it on the server and we got this type of performance, this type of core utilization, this type of power, whatever. And then after we got it with the DPYP, we got to this. So what are your plans?
F5 will be interested in providing that sort of information. I'm not sure. I'm correct me if I'm wrong, but I thought the OPI was not going to be in the business of providing that sort of information. I think we'll be providing that with each of our partner vendors that we run tests with, but I wasn't certain that we'd be providing a matrix of this card is better than that one because it did this faster.
No. So let me explain. That's not what I meant. What I meant is, for example, let's say that you have 3 cards in the lab.
Yep.
And the target is to reach 30 gig line rate, let's say. So we can say all 3 reach that, or wherever is the lowest common denominator, use that and say all cards reach that number. So there's no competition between the cards. But what we do need to do, and all cards need to make sure that they do, because that's the whole idea of DPYPU, is to make sure that we have a benefit versus an x86 or an ARM server. Meaning, how many cores are we saving? Well, how much power are we saving? So that is the important part for me. I mean, I understand that different cards will do better or worse on a specific job, but I think we need a lowest common denominator to show that we have performance. And I believe knowing the competition, knowing our cards, I think we'll do quite well. All of us. And the other thing, which is more important to me, which is what resonates with the clients I speak to, is how much am I saving? What am I saving and how much am I saving?
Okay.
And do you expect this to be sort of like a something that you could download and try? If it's not one of the platforms that you're using, will you put all of these pods out there for
other? We will put the Nginx pods out there, and the methods we got them installed, whatever automation that we have to get them installed, those will be out there. So a traffic source, a target, and the workload itself will all be, those pods will be delivered as a package that can maybe at some point be integrated into the lab that we have in Fremont, or lab we will have in Fremont. So that's the hope.
I have a question, Paul.
And we'd be happy to include a Mount Evans too, Dan, if we could get a hold of one.
Yeah.
Well, I have a question. Besides running Nginx on the ARM cores, what is the expectation of offloading the Nginx here? Is it like offloading layer 7 things, or URL stuff, or I'm just curious as to where that performance gain is being expected. I mean, you don't have to speak about any vendor, but I'm curious about the goal here.
Yeah, the goal for this project is to, we aren't expecting with this project for us to explore offloads of any of the functionality, I don't think. We're simply, this is more going to be a functional set of tests that we're looking to do that will help us understand what's the out-of-box experience for these cards, what's the out-of-box experience for provisioning them with the OPI APIs, and then you know, do we get somewhat better performance, or is it worse performance? I mean, that's kind of one of the things that we're wondering is how much we need in terms of compute on the DPU to run something like Nginx. Nginx is fairly lightweight. We've tried it on earlier versions of cards, and not been able to get very good performance with Nginx on those cards, just because there wasn't a lot of compute on them. Newer cards have a lot more compute. We think we'll be able to increase that.
Yeah, in that sense, basically, I think it answers Alad's question a little bit. I think in that sense, you're basically comparing the ARM architecture with Intel or in the x86 architecture, how well the Nginx program could run on ARM architecture versus not. So maybe I don't know if you will get magical results, largely because you're just running it. You're not taking advantage of the offload, which is what I think cards would give you better performance on. I'm pretty sure.
Oh, I'm pretty sure they would as well.
That's a good, yeah, long run. I think that should be the goal. But yeah, okay, thanks.
Yeah, Vipin, I would think that's a follow-on project for this. I mean, this is our sort of, can we take a generic app, Nginx, and have a way to provision and deploy it across multiple vendors' cards, right? And be successful with that.
Yeah.
And then measure the application sort of as an application without acceleration. And the concern isn't just the application, it's the ecosystem, right? It's the Red Hat underneath it, the OpenShift takes its own amount of compute, you know. So can we actually deploy a full-blown, you know, Kubernetes hosted ecosystem on one of these cards? These are the questions we want to ask. And we want to come out of it with a recipe that lets anybody do it for whatever app they want to try.
Yep.
And then I think a follow-on project was, okay, now let's take what we've built with Nginx and let's lean into the offloads and see what we can do to make it better with hardware acceleration.
Yeah, and
But
again,
what we don't want to get into is a boat race between cards. That's certainly not what we're trying to do.
no, and this is more about, if suppose you want to run something like Nginx, how hard is it to integrate and what does it look like?
Yep, exactly.
And that, you know, and that's an important thing to get across to the what I'd call the average user who might be interested in OPI. Why do you care about OPI? Oh, because look how easy it is to take something like Nginx, bring it up on a DPU and run it, or an IPU and run it.
Allow me to add to that. I think that indeed our main goal here is to show a workflow that could be followed for other applications, but also a process. So it will start with, as we said, putting the code, putting something on the ARM cores. It will continue with trying to improve it by using some of the offload engines, and eventually by releasing something that's turnkey. So it is a process, and we need to follow all of the, you know, all of the kinks and work them out, and then report on them as Paul suggested, because I think it's a very true to self statement that we understand how difficult or not difficult it is to bring something up like this.
Yep.
All right, perfect. All right. Talk to you guys next week in this call.
All right. Thanks
Bye-bye.
much.